Parallelogram ABCD has diagonals that intersect at point E. Which statement proves that ABCD is a rhombus? So in this scenario, we're actually going to want to draw a parallelogram. That way we could visualize everything that's happening here. And we want it to ultimately be a rhombus. So I'm going to try to draw a parallelogram that looks similar to what a rhombus would look like, with all four sides being congruent. That's a really bad one. Okay, let me try one more time. Okay, and I'm going to label my sides A, B, C, D. That way they connect in order. So for example, A, B, C, D. All right. And we know that the diagonals intersect at point E. So the diagonals intersect at point E. So now we're looking for a statement that is specifically true of a rhombus. So let's go through each option. So line segment AC is perpendicular to line segment BD. So we want line segment AC to be perpendicular to line segment BD. And what this is then saying is that the diagonals are perpendicular. And this is what would make it a rhombus. This is specifically a property of a rhombus. So our correct answer choice is number 1. But let's go through now and see why our other options are not correct. Line segment AC, instead of being perpendicular to BD, we're now looking at it as being congruent. This would state that the diagonals are congruent. But we know that this is a property not of a rhombus, but a rectangle. And we want to know which one proves it's a rhombus. So this is not going to hold true. All right, angle DEC is congruent to angle AEB. This statement is true, but this is just true because these are vertical angles. So if the shape were a rhombus, this is true in a rhombus, but this is not a property of a rhombus. These angles just happen to be vertical angles that are in a shape that could be a rhombus. So this is also not going to be one of our options. All right, and then lastly, AE is congruent to EC, and DE is congruent to EB. This is showing that the diagonals bisect each other. And this is true in rhombuses, but this is not specifically because it's a rhombus. This is just because a rhombus is a parallelogram, and this is the property of all parallelograms. So this doesn't make it a rhombus. The diagonals bisect each other in every parallelogram, a square, a rectangle, just normal parallelograms, so this specifically does not make it a rhombus. Therefore, our correct answer choice is number 1.